Welcome, friends! This is episode 16 of my Enigmatica 2 Expert Extended Playthrough series, and in the last episode we were able to streamline creation of these ender chests, which allow us to extract the results of our production, which happens away from our base, and then is getting sent through another ender chest to the main base and the main storage. It seems that my last episode was very well received, judging from so many encouraging comments I got from you. Also, you have reminded me that I am doing this for more than a year at this point, and all I can say is that I surely wouldn't be able to go this long without your warm support and creative feedback. So thank you so much for cheering for me along the way. This gives me lots of drive to push on. Also, in the comments to one of my previous videos, someone asked me to create a Discord server, and I thought to myself that after 1 year of doing this, why not? So now you can see a link to the Discord server in the description of my channel, and you can stop by and say hi, and we can discuss my playthrough or anything and everything. Speaking of Discord, last time we have also fixed our sifting building, and now the building is producing a couple different metals such as copper, tin and also uranium, as well as a lot of important materials for us, and we're doing this by burning ore pieces inside of a sear stone. Well, in the Modpack Discord, Modpack author Krutoy242 looked at my smelteries, which I used to produce sear stone, and he mentioned that these smelteries will be pretty laggy when I'm overproducing seared stone and the cobblestone is not getting smelted. How do we know this? Well, the pack includes a mod which is called LagGoggles. You can turn the mod on by pressing insert key by default on your keyboard, and here you can profile your world, for example for 30 seconds, and I will do this right now. After the profiling, the mod will highlight the blocks in your world and how many microseconds per tick of your processing power they are using. Another important feature of this mod is the Analyze Results table, where you can see every event and the entity which uses your processing power. Right away we can immediately see that the smelteries are the biggest offenders and they use more than 10 times more processing time compared to the foresters, which compose the next entry. One simple solution for this would be the separation of the cobblestone generator and a smeltery controller, and using XNet to transfer the cobblestone into the controller only when a smeltery is less than a half full. We can do this inside the XNet by setting a rule for the seared stone inside the smeltery and grabbing the cobblestone from the cobblestone generator only when needed. As you can see, now the smeltery is about half full and no cobblestone is getting added. Let's profile our world again. As you can see, our smelteries look much healthier now, and also our cobblestone generators are not waiting to send the cobblestone into the smeltery anymore and look much healthier as well. LagGoggles is a pretty cool mod, and I encourage you to use it to examine the performance efficiency of your setups, and I actually use it from time to time to gain a little nuggets of knowledge about how Minecraft works behind the scenes. And also behind the scenes, I have updated my modpack to the version 1.26.0, and now I also have this clock next to my map, which shows that currently I'm on day 1331. The statistics show that I have spent about 9.6 days in Minecraft, which equals to about 230 hours, but also that I have slept in Minecraft bed about 1200 times. Whenever night falls and I have to sleep in my bed, what I have to do is lay down and watch the screen fade to black very slowly. The sleep sequence only lasts for about 5 seconds. However, due to the sheer amount of times I had to sleep, I have wasted about 100 minutes of my life staring at the fading screen. And in the utility section, which honestly I should visit more often, there is a quest for us, for Sleep Charm, which grants you instant sleep. The recipe for it is very early game, and once you craft it, you can put it in any slot of your bubbles section. Now when the sun goes down, and we see the stars, we just right-click the bed and yep, that's it. Now that we have figured out how to save me 100 minutes over the next year, let's take a look at our progress board. So the next thing I was going to concentrate on was computers chapter. In order to get there, in the second Conflux level, you have to open the gate for computers by crafting a computer case, and even if the recipe is quite straightforward, I don't actually remember doing it, and I believe this happened because the previous versions of the pack had a different requirement for this gate, but we can can simply proceed to the computer chapter. Here we can do several things. We can proceed with your standard computers of OpenComputers mod, create electronic assemble to assemble robots and drones for OpenComputers, as well as go into computer craft and make its turtles. Let's start by creating a tier 2 computer case and getting into making a full computer. If we take a look at the recipe for the computer case tier 2, we'll see that the first component we need is simple machine parts, which we can acquire if we take a basic machine casing or advanced machine casing and blow it up for machine parts. Of course, the easy way of creating explosion is with Psy. For example, here there is a spell which will create a trick explode at the point where I'm looking at. The power of this explosion will be 2.15, and the reason for it is our current casting assistant device has a potency of 150, and if I increase this number just by a tiny little bit, the potency of the spell will be higher than something that we can cast. And the spell works like this. We can go to our testing stage here, set up the block, and then blow it up. But the problem starts if we put advanced machine casing or the basic machine casing and would try to do the same. As you can see, it doesn't work, and I'm assuming this is because explosive power 2 is not enough to blow up these casings, and we would need a higher tier of casting assistant device to get to a higher power, and I hope we can do this in the future, but for now, let's resort to a different method. This wasn't as spectacular as I thought because only one of these machine casings was converting at a time, but now we have 40 simple machine parts. The next component of the computer case tier 2 is a microchip, and the microchips can be made inside of alloy kiln from transistors and nickel ingots. However, I'm much more intrigued by a casting recipe which requires molten electronics. The recipe for molten electronics shows that we have to do something called barrel milking, where we place a Robit on top of a barrel, and barrel milking is a special type of recipe added by Modpack author Krutoy242, and we can go down this rabbit hole of checking out all of the possible recipes of different fluids which we can get through barrel milking, but right now let's just take a look at molten electronics. We can make Robit using pretty simple recipe with energy tablet, personal chest, and 2 water wheels. We will also need to charge the little guy, so let's craft the charge pad again using pretty simple recipe. We can put a charge pad next to the LV capacitor, which is charged by a single spectre coil, and then we just right click the charge pad with Robit. Robit is a neat little guy who we can use as a crafting grid, chest, smelting station, and repair station. Let's rename him Beep and touch the follow mode. Now Beep can follow us. We can give him a couple nudges to put him over the stone barrel. And as you can see, he starts generating about 10 millibuckets of molten electronics per second. As the recipe for the microchip suggests, let's put a casting table next to the barrel, put ingot cast onto the casting table, and then use flat transfer node onto the barrel. As you can see, after a while, we get ourselves a microchip. But as you can see, this way we can not only make microchips, but other things. In fact, there are 9 recipes, and each of the recipes uses either different way of casting or a different cast and certainly different amount of material. And we can use this mechanic to produce variety of electronic devices like this. So here I have increased the number of Robits to 3. They are producing molten electronics which is stored inside the iron drum. I have also set up a bunch of casting tables and a casting basin to cast the molten electronics, and then steel storage box to store the results. This system is very similar to my other XNet driven production setups. However, the interesting bit here is that I have 1, 2, and 3 connectors hidden behind the facade connected to this one steel storage box. And because each of the connector allows me to hook up 4 item storage rules to this one steel storage box, I can then cast only, for example, transistors when I'm missing these items based on the redstone signal. In practice, it works like this. Whenever I need my materials, for example transistors, I can come up to my storage box, grab a certain amount, let's say 6, and then the casting will start automatically, and it will happen until I will fill the amount of, for example, transistors back to the 64 as it's stated in my sensor rule. So I believe these 3 little guys will make our playthrough through computers chapter much easier. The last thing we need for the computer case tier 2, besides the obvious plates and a chest, is a printed circuit board. If we look at the uses, we'll see that we have about 17 pages of uses for the printed circuit board. It itself is made from raw circuit board, which in turn is made from a green die, gold ingot and clay, and you get 8 circuit boards per 1 gold ingot. So the obvious solution would be just to get 4 stacks of raw circuit boards, throw them all to be smelted, and just forget about it. Let's craft our first computer case of 2nd tier. On its own, it is just an empty box, it does nothing, however, it has places to put stuff in. It took me a couple minutes to collect all of the components, and I really want to thank our Robits because otherwise the crafting would take a pretty long time. I will not go through the recipes of all of these components because they are quite straightforward and you can just look them up in the JEI. And the last component we need to craft is a hard disk drive, so let me quickly do that and we can finish our quest. Now let's assemble our computer. First we put the case down, of course, then we can power it using a spectre coil and you can see computer case is getting power. Next we can place the screen on top of it, floppy disk drive to the right, and then we can put a keyboard next to the monitor. Now let's put all of the components inside the case. I'm using tier 2 central processing unit, 2 tier 2 memory cards, then a whopping 2 MB hard disk drive for file storage. Then for the card I will use a tier 2 graphics card, and I use a higher tier so you can see things better on the screen. Therefore, I don't actually have a place for the internet card, which was in a quest, but we can leave this for now because I'm not going to connect to internet right now. And finally, let's put our EEPROM containing BIOS, and our computer is assembled. However, just like in real life, our newly assembled computer is completely empty, and in order to run it, we need to install operating system. If we look at the quest rewards for the quest we just finished, the actual reward is OpenOS operating system on a floppy drive. If we take that floppy disk, insert it into the disk drive, and then turn the computer on, you will hear some sounds which some of you probably never heard before, and this is of a sound of computer starting itself up from a floppy drive disk. If we right click on the screen, it will become a little bit bigger, and we can see that the prompt suggests us that we need to install the operating system and then reboot. So let's do that. And the prompt asks us if we want to proceed. We say yes. And the install begins. After about a minute, the system says that installation is complete and asks us if we want to reboot. And after rebooting, our computer is all set with OpenOS version 1.8.3. We now have a working computer inside the Minecraft world. What's it good for? Well, I would love to show you a practical use for this computer, but first let us progress a little bit along the computers chapter. The next thing I would like to make is electronics assembler, which is good for assembling robots, drones, microcontrollers, and tablet computers. For such an amazing functionality, electronics assembler has a pretty straightforward recipe, and if we place it down and open it, in the top left you will see a slot where you can put various cases depending on what you want to build, and in the case of the robot we need a computer case. So let's just put a lower tier 1 case in, and you will see interface which is very similar to a regular computer we just assembled. However, in comparison to a regular computer you can see here, inside electronics assembler we can have 6 additional slots for the upgrades. If you look inside the JEI, you will see an impressive list of upgrades which allow Robot to do amazing things like chunk load, or use crafting, or generate power from coal, or handle fluids, or attract items. A lot of cool stuff I would like to try. But in order to assemble the robot, we will need to fire up the assembler, of course. And the next quest for the simplest robot tells us that the assembler will consume 1000 RF per tick and will require 700,000 RF to complete the robot. We could of course slap a single spectre coil on the assembler and just wait longer, but it turns out that in the computers chapter there is much more elegant solution. Well, first we need to craft a capacitor. Capacitors have very cheap recipe and are made from basalt, gold nuggets, transistors and printed circuit boards, so let's just craft 16 of them. And immediately the next quest in line is for carpeted capacitor, and you can see that if we just slap a carpet on our newly created 16 capacitors, we will get a machine which generates power when sheep or ocelots walk on them. And power will be generated only when there are at least 2 animals of the same type are present. This is not a problem, but 2 ocelots produce a whopping 600 RF per tick, and that should be enough to power our electronics assembler. I have bumped the amount of capacitors we have to 25, just so our ocelots have an ample space to run around, and crafted 25 carpeted capacitors. I have built this nice little pen for our future charging needs, however, it is missing ocelots. Luckily, they are on sale in our market. The price is a little bit steep, however, I'm sure it will be worth it and fun. We can place these 2 ocelots in a pen, and then use the name tags and right-click on them to prevent them from despawning. As I was observing my ocelots, I noticed that when they are not standing on one single carpeted capacitor or next to each other, they don't generate energy, so I reduced the size of the enclosure, and also when they start jumping around, they don't generate energy as fast, so I have placed this couple pieces of glass above to prevent them from jumping. Now, if we look at our electronics assembler, we see that we get a steady stream of energy, and we already collected a lot. But this energy doesn't come for free. If we look at our ocelots, you can see that they have lost some health, and this is not because of the poor living conditions, even though the enclosure I put them in seems small. So our ocelots will take damage once in a while, and if you don't take care of them, they might die on you. And of course, the simplest way to fix this would be using a brewing stand, and in 4 steps we can brew a level 2 splash potion of healing, which would heal our ocelots. To run this process once, we'll need some nature assets to make a melon, 8 gold nuggets, nether wart, glowstone dust, gunpowder, and 3 glass bottles. As you can see, while we were making the potion, OpenComputers Ocelot managed to lose a full heart. Let's try to heal him. The healing works nicely, but I would hate to waste my time just standing by the brewing stand and replacing components by hand. And this, I think, is a nice little project that OpenComputers can help us with. There are of course several other ways one can use to brew the potions, and also you could heal the ocelots using other means than healing potions. But to be honest, I haven't seen a lot of practical tutorials for OpenComputers, and I believe automating the brewing stand with OpenComputers is a simple enough topic that will serve as a great introduction to the OpenComputers mod and how it works. Let's take a look at what do we have here. If I right-click on the computer screen, I would be brought inside the command prompt of the Lua language, and if you know Unix Linux commands, then you will be very familiar with what you can do over here. But if you are not familiar with Linux commands, don't worry, I will introduce just a couple of them to you, and you will be able to do anything you want in no time. The first command I would like to introduce is change directory command, or cd. If you want to go up a level in your file tree, you place cd ... hit enter, and now as you can see, we went one directory up. If we want to go back to our home directory, we would say cd home. Let's go up a level again, cd ... and now I would like to teach you another command, list, which is spelled ls, and that command lists everything you can find in the directory you are currently in. So currently we're sitting in the top directory and we see all of these folders in blue and all of the files, which currently we have just one init.lua, in green. So with just two of these commands, cd and ls, we can travel around the hard drive and look at the files there. For example, now we can go to the lib directory and then list the files inside, and we can see quite a lot of the functions inside the library directory. Or we can go back a level and then go to our home directory, and here we can start creating some files. But first I would like to show you another command, which is clear command, that removes the clutter, which is the result of the previous output, and makes reading much easier. First, let's take a look what is inside the home directory, and as you can see there is nothing in it. Therefore, we can create a file. The most obvious example of a file in any computer language training is Hello World program. So let's make one. To do this, we need to create a file. The edit command will create a file if it doesn't exist and will edit it if it exists. So let's type edit hello.lua and hit enter. And as you can see, we are now in the text editor. Now we can write some simple code. For example, I can write print hello world. As you can see at the bottom of the screen now, there appeared a couple commands. For example, if we would like to save the file, we can press Ctrl S, and as you can see after I did that, it says that the file was written. Another command is Ctrl W, which closes the file and comes back into the home directory. Now, if we list what's inside, you will see that hello.lua appeared in our home directory. The file we just created has a .lua extension, which means it's a Lua script. In order to run this script, we first need to start a Lua interpreter by typing Lua, and then we would need to type the name of the script. However, OpenComputers mod is smart enough to use autocomplete. For example, if I just type H and then hit tab, it will autofill the file name by looking what's inside the directory, and now if we hit enter, as you can see, Hello World was printed as an output. So here, in about 3 minutes, I have showed you how to navigate OpenComputers file system, how to browse the files on your hard drive, how to create new files, and we even created a very basic Lua script and executed it. This might not seem much, and indeed OpenComputer system can be much more complex, and you can actually read the full documentation on official documentation site for OpenComputers, but I'm telling you that what I just told you is completely enough to actually start progressing in the OpenComputers mod. So here I have built a computer which looks exactly like the one I was just showing you. Again, it has a screen and a keyboard attached to it. I have deleted the disk drive because I have already installed the operating system on this one, and right next to it you can see the brewing stand. And so my question was, how do I automate the brewing stand so I can produce healing potions to heal my Ocelots using OpenComputers? And I have solved this problem, but I wanted to tell you that before solving it, I had absolutely no idea how OpenComputers operate. So I believe the method which I used to do this will be applicable to many practical problems you might have, and I think that if I could do this, you can do this too. And of course, in its core, the solution is very simple. If you have a crate and inside you have the components you would need to start the brewing, and you can somehow transfer the components into the brewing stand, the brewing will start. But how do you do the transfer? Simply searching over the internet about the ways to transfer items between containers and OpenComputers brings you to this page that discusses a transposer, a component in OpenComputers that can be used to inspect the contents of adjacent inventories and moving items between them. And on another page you can find a list of callbacks that Transposer is using. And if we look, one of them is to actually transfer items. It lists the source site, the sink site, how many items you want to transfer, the slot in the inventory you transfer from, and the slot you transfer to. The recipe for the transposer is quite simple. Besides the vanilla components you can see here, it also requires a couple inventory controller upgrades which we'll be using for robots and drones a little bit later. The inventory controller one requires some basalt, microchips, and then this inventory rerouter, which again just slightly more basalt. And then the TAN controller upgrade is slightly more expensive because it requires some gold ingots, but again, pretty straightforward recipe. We can place our transposer right next to the brewing stand and below the wooden storage crate, and it will be connected to our computer. And we know it is connected because if we just type components here, we will get the list of everything that is connected to the computer. And as you can see, there is this line here and it says that the transposer is connected. Alright, so we can place our 3 water bottles and a nether wart inside the wooden storage crate. And now we need to figure out the way to use this transfer item callback for the transposer, which I highlighted earlier. I will be using ChatGPT for this purpose, and I know it's not available for everyone, and potentially you could teach some of the documentation to the local coding model, or simply Google every answer for your programming needs in OpenComputers. However, I believe ChatGPT, since it is available for me, will act as a great shortcut for me to understand OpenComputers mod quickly. So here I'm telling ChatGPT that I'm using OpenComputers mod, and I would like to move an item from the chest into the brewing stand using the transfer item callback we discovered earlier. ChatGPT responds with the following code snippet, which supposedly does exactly that. So let's copy it, get back to our computer screen, and type edit item transfer.lua. This brings us to the new file, and we can insert the contents of the ChatGPT command by pressing middle mouse button, and then we can save it using Ctrl S and finally Ctrl W to close the file. We can test our new script just like before by typing Lua and then the name of the script, item transfer.lua, and the output shows it was a success. But of course I'll believe it when I see it. So let's check. The brewing stand has now one water bottle, and a wooden storage crate has one water bottle missing. So indeed the transposer moved the water bottle from the crate into the brewing stand. Alright, now that we have learned the basics of operating OpenComputers in-game, let's break the fourth wall and see how we can make it easier. If we go into our Minecraft instances folder, then into our pack folder and select saves, and inside you can see our current save. For me is Enigmatica to Expert Extended Season 1, and inside there you can find OpenComputers folder. If you open this folder, you will see a couple things. Depending on how many computers you have built in game, the amount of the folders in here will be different, but each of this folder represents a separate file system. If we turn our computer on and see what components are in there, you'll see that we have two file systems in here. One starts with 363 and another with 7A1. With the help of ChatGPT, I have built a simple script that tells us where these two file systems belongs, and you can see that the one which starts with 363 is the one onto which we installed our OpenOS operating system, and the second one is just a temporary file system. Now if we go back to our OpenComputers folder, we will find a folder with exact same name starting with 363 is our operating file system. If we get inside it and into the home folder, we can see all of the files which we are created earlier in the game. The reason I have discussed how to locate this folder is because later in the game we can have 20 computers installed in game, and so in order to locate the specific one, you will have to log in onto one of these computers, check the components, and note the name of the file system. What's great about accessing these files directly is that you can open them in your favorite text editor, and in here we can change anything we want. For example, I will change this colon to the word is, then I can save the file, go back into the game, run the same script again, and you will see the changes we made to the script immediately take effect without us needing to restart the Minecraft game or even the computer inside the game. I am sure editing files like that will make our life much easier. However, we can do even better. We can download a free software called Visual Studio Code and install it on our computer. Visual Studio Code is a great environment where you can create and edit your code, and once you install it, it will look like this when you start it for the first time. So you can click Open Folder, and inside your OpenComputers, select the folder with the file system which we need to open, and click Select Folder. Now we are having access to this file system and to every folder inside it. If we go into the Home folder, for example, we can open the file check.lua, and we can see its contents, and we can also edit it and save it. But if that wasn't good enough, we can do even better. If we go into the Extensions tab and search for OpenComputers.lua, we'll find this extension which basically adds OpenComputer syntax highlighting and code completion. We can click Install, and once this extension finishes installing, we can go back to our check.lua file, and now you can see that the color scheme changed a little bit. For example, the word component here is highlighted. If you Control-click on a link, it will bring us to the OpenComputers documentation about the component API, and we can read all the documents about it. I think the addition of this extension and the ability to edit files like that will do amazing things for our coding journey. We are almost ready to start our automation of the brewing stand programming. However, besides just knowing how to move an items between the storage crate and a brewing stand using OpenComputers scripts, there is one more thing which would be nice to learn, and that is the progress bar inside the brewing stand and how long does it take to brew a potion. The thing that potentially can help us with that is the adapter from OpenComputers, and it has pretty simple recipe with just a couple cables which are made if you surround redstone with iron nuggets. The reason I have said that the adapter has only a potential to help us is in a tooltip, and it basically says that the adapters is used to control vanilla or modded blocks which are non-components to the OpenComputers mod, but it doesn't exactly say what functions will be available to us. In order to control the brewing stand with the adapter, we need to place adapter right next to the brewing stand and then use the cable to connect it anywhere to the multi-block structure of our computer, so I have hooked it up to our transposer. If we get back to our computer screen, you can see the result of the components command I ran before connecting the brewing stand, and you can see that the brewing stand is not in a list. So now we run the same command again after placing the adapter, and you see the brewing stand in the list, so now we can control it. So what can this neat little block do for us? Well, let's ask the computer. First, we can enter the interpreter by typing Lua, and then we can load the component module using require component function, and then ask it what brewing stand does. As you can see, this line of code prints on the screen what the adapter can do for the brewing stand. However, this block of text is not very nice to read, and judging by the 3 dots below, this is not even a full list. So instead, I have created a simple script which takes a component name such as brewing stand as an argument, then it creates a text file in our local home directory, and then it writes everything you just saw on the screen into that text file. So let's try this out, shall we? All we need to do is to start the script using brewing stand as an argument. Once we hit enter, as you can see, it tells us that it finished writing the file. And right away inside our Visual Studio Code, you will see this brewing stand help.txt. And if we look inside this file, you will find a neat little list of all the functions that are available to us for the adapter to control the brewing stand. And here you can see the very first entry as the getBrewTime function. And what this line tells us is how we run this function. It has no arguments. What it outputs a number. And what does it do? It gets the number of ticks remaining for the current brewing operation. This is exactly what we need. Brilliant. I don't know about you, but this feature of OpenComputers excites me to no end. You know, to me, the world exploration is really important feature of Minecraft. You can find weird things in the world and then spend time examining how you can use them for your benefit. And peering deep into the OpenComputers code, I feel very same exploration excitement. For example, here is very ordinary apiary from forestry. You can place it down and grow bees inside. But let's hook it up to the adapter and let's use same exact script to take a look at what BeeHousing component does. And in the output list, we can see lots of interesting and exciting functions such as get the queen, or get the bee parents, or get the drone, and most interesting, get some sort of bee breeding data, which apparently is a table which contains the breeding list. I don't do this too often, but at this point, I would really like to know from the comments below if there is a single person among you who is not fast asleep at this point and is as excited about these things as I am. But going back to the brewing stand, let's check out how this new function getBrewTime works. First, we enter the interpreter, of course, and then we ask the brewing stand component how many ticks it has yet to work. And the answer is 0, of course, because nothing is cooking. But if we take the rest of the components from the storage crate and deposit them and the brewing process starts, we can go back to the computer and check how much time is left. And as you can see, the number of ticks starts going down as the brewing stand finishes our potion. So at this point, I have explained all of the tools and building blocks that one needs in order to build brewing stand automation script. Welcome to the virtual planning environment. I don't think it's really helpful to show how I developed every line of code I have, so instead I would like to show you the guiding principles which I used in order to build my code, and hopefully if you get inspired by this video you could use these principles for another project. The main thing I would like to show here is that building a script like that is not really hard, especially considering we can use great tools like large language models in order to help us to build the code. So let's take a look at the problem at hand. As an example, if we want to create a splash potion of healing level 2, we need to go through a series of steps. However, every step in this list is an isolated brewing event, so if we can figure out one of them, we can do all of them. There are a couple elements we need to worry about when we are discussing a single brewing event, and these are the potion ingredient, the starter potion, the resulting potion, and also we need to keep an eye on the complexity, and that is how many steps do we need to get the potion from scratch. These describe the items that are related to the brewing process, so now we have to discuss the item flow. As I mentioned earlier, transposers from OpenComputers will be doing most of the handiwork here, and so it is quite obvious that probably the ingredients and the starter potions should come out of the components chest and be moved into the brewing stand for brewing, and then the resulting potion should be moved into the results chest. However, we shouldn't forget about the complexity, and so sometimes the resulting potion from the brewing stand has to come back into the components chest for a more complex brewing. So now let's think about how can we organize such brewing into the script, and one thing we'll definitely need is a recipe library, which will connect the particular resulting potion with its ingredients and starter potions. The bulk of the script will consist of several functions which will perform various tasks. There will be a function that is asking user what potion they want to brew, another one that is asking how many times brewing needs to happen, yet another one that is asking at what complexity level we want to start, in the case we don't want to start from scratch. Noting the user input from these three functions, the next one will talk to the recipe library and figure out all of the ingredients that are needed in order to finish the brewing. With this information, another function will check the components chest in order to find all of the ingredients and their locations, and if some of them are missing, will message the user to add them. Next function will basically embody the logic we had behind the item flowchart and will figure out where each item needs to be moved. And finally, based on the outputs of all of the functions above and a brewing stand timer, the final function transfer item will take the right item from right source and will send it to the right destination. What's great about these functions is that they are self-contained, which means that we have 7 bite-sized problems with very particular input and output, and once we solve all of them, we can combine them together into a nice working script, and as we work on each one of them separately, the others are not affected. This approach also helps me with my sanity, because when, for example, I was thinking about the full script of brewing automation, I was really concerned about its complexity, but once I look into a smaller problem, for example, like the function to find an item in the chest, the problem doesn't feel too bad, despite the fact that solving this will bring you closer to solving the big one. Back in the Valley, I have rearranged our setup a little bit. Now we have 2 containers. One is an output container, which is wooden storage crate, and one is an input container, which is iron storage box. I made 2 of these containers of a different type, so it is easy to distinguish between them when we are coding our script. I also now have 2 transposers. One is above and one is to the side of the brewing stand, and the reason I did that is because for the brewing stand, just like the Minecraft furnace, the sides matter, meaning you can only insert ingredients from the top and the bottles from the side. Finally, I have an adapter right next to the brewing stand, which will tell us how much brewing time we have left on every operation, and all of the components for OpenComputers are connected to the computer using the cables. Now that we have all the blocks in place inside the Minecraft world, we can go back to our Visual Studio Code and to our file system, and in the root folder of it, we can create a new folder called data, and here we are going to create our potion library. So inside the data, we can create a new file called recipes.txt. Once we open the file, we can populate it with our recipe library. And here it is. This list can be much longer since we can brew anything we want using this script, but for now we are only interested in Splash Potion of Healing 2, so our list contains 4 entries. You can notice that each entry consists of 4 elements. The first one is the name of the resulting potion which we want to use. This can be anything you want as long as you recognize it. The second element is the Minecraft in-game name of the starter potion, and the fourth element, the last element, is again Minecraft's in-game name for the ingredient for the brewing. And here the third element, this cryptic number over here, is actually the level of alchemy for the starter potion. The reason I have added alchemy level in there is because of Minecraft naming conventions. Unfortunately, in Minecraft, two different potions can have same exact name in white, but different tooltip in blue, and then opposite might happen. Two potions can have a different name, but same exact tooltip in blue. I could define the unique potion by using its name and a tooltip. However, it turned out that the tooltip information was really hard to access with OpenComputers, so I have resorted to the Thaumcraft elements. If you look at the leftmost one, the alchemy level, then you will see by comparing the name of the potion and alchemy level that every potion can be uniquely distinguished between the two things, the name and the alchemy level. And with alchemy level being super easy to access through OpenComputers, I decided to use this combination in my script. Now that we are done with the recipes, we can go into the lib folder, and here we can create a library of functions called PotionLib.lua. You can see that I have already populated this file with the functions, and not only that, I actually tested it to see that it works. I think it will take rather long time for me to go through this file in great detail and explain everything that it does, and instead what I'm going to do is share the link to my GitHub page in the description, so you can go there and check it out. However, what I can tell is that this file strongly adheres to the planning section. For example, these three functions here are exactly same as we planned. In other cases, I would split the initial function that we planned into even smaller chunks for better understanding. For example, here I have a function which finds the items in the inventory and another function which finds potions. And the reason I split them is because for the items we just need to know the container name, the item label, and the site we're looking into. However, for the potion, like I told before, we need an additional alchemy level. In total, there are 15 functions in this library, and the process of development of every one of them was very similar. Take this function getRecipe, for example. I would give ChatGPT very specific instructions to generate me a function for Minecraft's OpenComputers mod that would take a user input in the form of string, compare it to every entry inside already existing potion recipe library, and if the potion is found, return me the potion entry, and if not, return me a nil value. Once the code was generated, I would run it on its own, adding a couple debug lines like this to actually see what function is doing, and once I'm satisfied and I see that everything is working perfectly fine, I would add this function to my PotionLib function library. I have repeated this process 15 times and I have tested every one of these functions separately. I'm not going to lie, this took me 5 to 6 hours to complete, but as someone who was doing this for the very first time, I felt that it wasn't as hard as I initially imagined, and along the way I gained a lot of knowledge, so I'm sure the next project like this will be much easier for me. Once my function library was complete and working, I could go to my home directory and create the main script which I called AutoBrew.lua. Since my function library is doing most of the work, all we need to do is load it up, then locate the three main components which we are using, which are the brewing stand, the input inventory, and the output inventory, and finally start the brewing process. After all of these preparations, I hope you are eager to see how this all works in Minecraft world. First, we'll need to load up our input iron storage box with bunch of water bottles and ingredients for the brewing, and then the only thing is left is to waltz over to our computer and type AutoBrew. Once the program starts, it will ask us which potion we would like to brew, and it pulls this name from our potion recipe library. Obviously, in this case, I would like to brew the very last one, Splash Potion of Healing 2, so I press number 4. Now it is asking me which potion I would like to start with. In the case, I pre-made some of the potions. However, we are starting from scratch, so I'm pressing 0. Now it is asking me how many times I would like to make the brewing happen. I will type 9. And the program reports that it is brewing an awkward potion. Indeed, as you can see, the starter potion and the ingredient was loaded up, but the brewing is awfully slow. Let's speed it up using time in a bottle. If we look inside the container now, you can see that the water potions are slowly being replaced with an awkward one, and after that stage was complete, we are getting potions of healing. This is the final stage. This is where the Splash Potion of Healing are converted into the Splash Potion of Healing level 2, and this is why they are deposited in the final output chest, because this is not a component anymore. Our computer screen proudly presents that the brewing is complete, and we are staring at the full storage crate of Splash Potions of Healing level 2. Both of our Ocelots are actually in dire need of healing at this point, so let's help them out. I'm sure just a couple of potions will do. But of course we would like the healing to be done automatically, so I hooked up a crate full of potions to the dispenser, and then on the other side we have a timer which is set for exactly 7 minutes, so every 7 minutes a potion will be dispensed onto these cats, and if I ever see that they are dying too fast, I have a lever here, so I can heal them up when I need it. This was a type of video I myself wanted to see when I first bumped into the OpenComputers mod. I hope I've shown how one could start this mod from scratch and finish a simple project. I intended this tutorial to be an inspiration to dig deep into the OpenComputers mod, as I believe gaming should not only be fun, but also a creative and learning activity. I will share a link to all of the code I used in this episode in the description, and going forward, I will show less of the actual code in the video now that you have seen my work process. Also, I will be happy to discuss it with you down in the comment section or in my Discord. Speaking of going forward, I think I will go back and dive right back into the Robot questline, as Modpack author Krutoy242 added his awesome framework called Lost User that will allow us to simplify and in many cases eliminate the coding for many common tasks. But for now I will be signing off. Thank you so much for watching, and I hope to see you all next time. Same place.